When watching a beautiful sunset over the sea and in the mountains, have you ever thought about what a sunset on Mars looks like? Or on Venus? Do they have the same reddish hues as sunsets on Earth? Not really. You see, sunsets look very different on different planets because of the composition of their atmospheres. Sunlight scatters off of the molecules that make up an atmosphere. This process is more effective at shorter wavelengths, which is the blue end of the visible spectrum. That's why we perceive the sky on our home planet as blue. But at sunset, light needs to travel longer distances through the atmosphere. That's why we see yellow and red hues. Now, let's move to Mercury and check what sunsets look like there. Both sunrises and sunsets on Mercury are views to behold. The sun seems 2.5 times larger in the sky over this planet than when you look at it from the surface of Earth. It also rises and sets twice during a Mercurian day. It rises, arcs across the sky, stops, moves back to the rising horizon, stops again, and restarts its way toward the setting horizon. Such bizarre maneuvers occur because Mercury rotates 3 times for every 2 orbits around the sun, and its orbit is extremely elliptical. But if you expect to see a blazing sky and the hues of red, you'll be disappointed. Mercury has almost no atmosphere, so its sky is always black since light doesn't get scattered at all. Let's continue our journey and go to Venus. There, at sunset, a bright yellow fades into orange, brown, and then when the sun disappears, black. The planet rotates on its axis very slowly, so to see a sunset, you'd have to wait almost 1/16 times as long as you would on our home planet, half of a Venusian year. Mars is widely known as the red planet because of its rusty color caused by the presence of iron oxide in its soil. But sunsets on this planet would look surprisingly blue if you watched them from the surface of Mars. Fine dust in the atmosphere of the planet scatters light and makes the blue hues around the sun's area of the sky brighter. A Uranian sunset is azure, fading into royal blue with some hints of turquoise. The pretty colors come from the interaction of sunlight with the planet's atmosphere, which mainly consists of hydrogen, helium, and methane. These gases absorb the longer wavelength red portion of the light, and the shorter wavelength blue and green light gets scattered when photons bounce off the gas molecules and other particles in the atmosphere. In 2014, scientists working with data received by NASA's Cassini mission showed what a sunset on Titan could look like. The largest moon of Saturn is surrounded by haze and smog. It's the only satellite in the solar system with a measurable atmosphere, which mostly consists of nitrogen, around 95%, and methane, about 5%. High in the atmosphere of this moon, the nitrogen and methane get split apart by the ultraviolet light from the sun and high-energy particles accelerated by Saturn's magnetic field. The compounds produced during this process create a thick, orange-colored smog. As the sun sinks toward the horizon, these orange hues turn into a deep brown. Now look at this. It looks like a sunset on Earth, right? But it might actually be what it looks like on Saturn. We have to say might because, just like all images from space, we can rarely get the color right. They are neither true nor false. They just represent the physical processes underlying the subjects of the images. As for the photo of a sunset on Saturn, it's hard to say if it looks exactly like this before we get more scientific data.
We've sent more spacecraft to study the local environment on Mars than on any other planet. We have no evidence that life exists on the red planet or ever did, but that didn't stop some people from wondering. Mostly because of the pictures that NASA's Perseverance and Curiosity rovers take regularly of Mars' surface. Feel free to check them out for yourself on the internet. They are free for anyone to see. Over time, some odd shapes have appeared here and there in these pictures, making some people believe there is some sort of creatures living there already. Back in 2008, one of the rovers took a picture of a rock that looked very much like a female figure. Other photos seem to show animal-shaped figures, utensils, or other Earth-like objects. Again, there is little to no proof of this theory, as rocks can be of all sorts of shapes and sizes. But if you look at the pictures, it does make you wonder. A lot of people in the scientific community do see Mars as a better place for long-term settlements, even though our moon is closer. Firstly, because it's believed there is indeed water on Mars. It's just stuck in underground frozen lakes. The soil doesn't seem to be rich in nutrients, and it may have some harmful chemicals. Moreover, on the red planet, the gravitational pull is only 38% of Earth's, so it's easy to carry heavy objects here. On our moon, for comparison, the gravitational force is only about 16 and 16% of that found on Earth. We already have people studying how we might live on Mars right here on our planet. It's because certain regions of Earth closely mimic the harsher conditions on Mars. Devon Island, for example, is the biggest uninhabited island on our planet, located in the Canadian Arctic archipelago. It's easy to see why it's hard to live here. The soil stays frozen all year. The eastern part of the island is covered by a thick ice cap all year round. Summers here only last for less than 50 days and aren't really that warm. Not a lot of plants can grow here, so no animals can adapt to thrive and multiply. As such, the Hutton Mars project started here in 1997 to offer astronauts unique studying opportunities. There are few options here in terms of logistics and transportation, and communicating with people living outside the island is also a bit more difficult. All because of the temperature and barren soil. Think about it, if we can find solution to live here, we might be able to do it on Mars too. Regardless of our local training, the conditions on Mars are currently inhospitable. That's because it's really cold. On average, the temperature is about -81 Fahrenheit. Even during the summertime, it's never hotter than 86 Fahrenheit. And to top it all off, the planet's atmosphere is made of 95 and 3/10% carbon dioxide, so there's literally no way we could breathe there without special devices. Mars also lacks a magnetic field on its surface, so it is attacked by the sun's radiation. Because of the temperature variations, Mars often experiences powerful dust storms, which can surround the entire planet. Technically, these storms can physically harm us, but the dust might clog electronics and render solar-powered instruments unstable. We know now that life as we know it is impossible on Mars, but did it ever exist there? This is a question long debated by scientists, since NASA's investigations have determined that some parts of Mars were habitable at one point. We don't know for how long or how far back, and just because something could have lived there, it doesn't mean it actually did. Other recent photos from Mars showed a cloudy sunset. Does that mean it also rains on the red planet? Well, not really. For starters, on our planet, clouds are water vapors, and once it starts to rain, the water reaches the surface of our planet in liquid form. This process isn't the same on Mars. Surprisingly, there is more water in Mars clouds, but they're made of iced water. Think of them as a tiny icy fog. Combined with the thin atmosphere and cold temperatures, it keeps the clouds from ever falling to the surface. Sunsets are different here too. According to NASA specialists, there is some fine dust that makes the blue near the sun's part of the sky much more visible on Mars, so the sunsets here have more of a bluish tint. Similar to Earth, Mars is also tilted on its axis, which means it also has seasons. Because the southern hemisphere is directed away from the sun when Mars is farthest from it, the winters here are far colder and summers way hotter. Calendars work differently on Mars too. A year here lasts for about 1 1/8800th Earth years. A day is a bit more longer than 24 hours. Even if we were to ever move to Mars, we'd still have to communicate with our Earth. It would be a bit difficult to do, since a message sent back home would take about 15 minutes to reach its destination. It's not that bad given the entire distance, but it would make video calls kind of annoying. As difficult as it might be for now to live there is a lot of stuff to see. Some scientists believe that if we were completely colonize Mars, a list of locations would soon be declared national parks. like the area surrounding Olympus Mons, which is the biggest known volcano in the solar system, stretching over 16 miles. Valles Marineris would be another cool location. It's been a huge complex of valleys about the distance from Los Angeles to New York. Mars also has some cool polar ice caps, which sometimes experience dry ice snowfall. Saturn and Uranus are unique planets in our solar system because of their rings. It may not have one now, but Mars may be getting a ring of its own in the future. Don't get too excited. It's estimated it might take 10 of millions of years. Mars' largest moon, named Phobos, will be torn apart at one point. The debris resulting from it will settle in a rocky ring around Mars, resembling that of Saturn and Uranus. Speaking of moons, Mars has two of them that we know of. Apart from Phobos, there is also one more object called Deimos. Both were discovered by an American astronomer named Joseph Hall back in 1877. The scientist had almost given up his pursuit to find Mars moons, but thankfully he was urged to continue the project. The next night he stumbled upon Deimos. 6 days after that initial finding, Hall found Phobos. These two space objects may be in fact some asteroids captured by Mars gravity. Another theory suggests they formed in orbit around Mars at about the same time the planet came to be. The fact that Mars has a really weak gravity may also be the reason for this fascinating event. Mars was hit by large asteroids many years ago, just like our planet was. A lot of that debris surely went back to the surface, but some of it was ejected back into space, as Mars' gravity wasn't strong enough to pull them back. They had quite a journey, some of them even ended up on Earth. These pieces of Mars also helped us understand the planet's unique features. We've continued to send robots to the Red Planet quite successfully in the past few decades, but it still remains quite difficult to imagine people will soon land on Mars. Even considering the current rocket technology, the journey would take us 6 months. And that's an optimistic scenario, given everything goes well on board. After landing, humans will be exposed to deep space radiation and microgravity. Both of these have serious effects on the human body, which we've yet to figure out how to counteract. That's why research is continuously performed on the International Space Station regarding the long-term effects of microgravity.
We finally know when Earth will cease to exist. It'll happen when the Sun enters its red giant phase. Are we going to survive long enough to witness it all? Let's figure it out. In 5.4 billion years from now, our star, which is a yellow dwarf at the moment, will run out of hydrogen in its core. The Sun's core will heat up and become denser, causing the star to grow in size and turn into a red giant. The expanding Sun will get so huge that it'll encompass the orbits of Mercury, Venus, and probably Earth. Even if our planet survived being consumed on the spot, it'd still end up so close to the heat of the newly born red giant that it'd scorch our planet. No life would be able to survive there. At the same time, there might be another outcome. As the Sun expands, Earth's orbit might change too. You see, when our star reaches the final stages of its stellar transformation, it will lose unimaginable amounts of mass through extremely powerful stellar winds. It'll keep growing and losing mass, making the planets of the solar system spiral outward. So can it help Earth escape its dooming grasp? According to astronomers' calculations, our planet will not survive the expansion of the Sun in any case. By the time our star reaches its largest radius, which is going to be 256 times its current size, it'll be down to a mere 67% of the mass it has now, and the expansion process will be very rapid. The Sun will sweep through the inner solar system in only 5 million years. At one point, it'll enter a short helium-burning phase, which will last around 130 million years. During this time, it will expand beyond the orbit of Mercury. After that, the Sun will swallow Venus. By the time our star approaches Earth, it will be already losing as much as 8% of Earth's mass every year. Speaking of our planet's chances, we've got some kind of a good news, bad news situation on our hands. The bad news is that our planet won't be able to live through the expansion of the star. Even if Earth's orbit became 50% more distant from the Sun than it is today, it'd still have no chance. The Sun would engulf our planet even before reaching the peak of its red giant phase. After that, the star would still have 500,000 years and 0.25 AU to grow. Once Earth is inside the Sun's atmosphere, it will start colliding with particles of gas. Its orbit will begin to decay, and the planet will spiral inward. If Earth was just a bit farther from the Sun right now, at 1.15 AU, it would survive the expansion phase of our star. But what can be considered good news in such a tragic situation? Well, long before the Sun enters this red giant phase, the habitable zone around it will be gone. The heat from the Sun will evaporate Earth's oceans, and solar radiation will blast away the hydrogen from the water. Devoid of its main source of life, Earth will eventually become molten. It doesn't sound like good news, that's true. But the upside of this situation is that humanity will be bound to leave our planet long before it gets swallowed by the Sun. We just won't have a choice. Of course, we can't be sure that some other catastrophic event won't claim us before we have time to colonize some other world. An additional benefit of the changing boundaries of the Sun's habitable zone might be the restructuring of the entire solar system. Even though Earth won't be in our star's habitable zone anymore, most of the outer solar system will be. This zone will stretch well into the Kuiper Belt, which means that the formerly icy worlds will melt and liquid water will appear beyond the orbit of Pluto. So maybe that's where our new home will lie.
Move over, Star Wars. Astronomers have discovered an exotic star system that puts you to shame. Did you know our solar system is a bit of a loner in the galaxy? Most stars actually have companions, and some even have multiple. For example, binary star systems are very common, consisting of two stars orbiting around a common center of mass. Usually, you can't see them with a naked eye. To an observer on Earth, they'll most likely mold together and appear to be one. For example, Alpha Centauri A and Alpha Centauri B together form a binary system. They're some of the brightest stars in their constellation and the third brightest in the night sky in general, outshined only by Sirius and Canopus. But if you look at them, they'll appear to be a single star. Although it's not always like this. There are also so-called double stars. They're located so close that they may seem like a binary system, and they can either be one or not. You can even do a little eye test. In the Big Dipper constellation, try to look for Mizar and Alcor. They're kind of hard to spot, but they're right there on the arm of the Big Dipper. Now, if you're able to see them not as one, but two, then you have good eyesight. And hey, why settle for just two stars when you can have more? Triple systems are also quite common, with three stars orbiting around each other in a delicate cosmic dance. These systems can be full of surprises because the orbits are so difficult to predict. But all this pales in comparison with the recent discovery. A few years ago, a team of researchers discovered an actual five-star solar system. It's located 250 light-years away in the Ursa Major constellation and was discovered by the Super WASP project. All of the stars there were formed from the same disk of dust and gas, and now they're connected in one complex gravitational dance. Now, this doesn't mean they're all incredibly close to each other. They don't do some kind of a square dance, you know. In fact, they're separated by more than the distance of Pluto's orbit around the Sun. Usually, such large systems consist of smaller ones. For example, in this case, there are two stars that are super far away, two stars that are so close that one is practically stealing the other's hydrogen, you bad boy, and one tag-along lone companion. But they all orbit around a common center of gravity. With all these interactions, it's a wonder they don't collide and create one big bright mess in the sky. But it's not surprising that each such system is more complex and rarer than the previous one. And this all raises the question, what kind of unique environments could exist in such systems? What would our life look like if we lived there? Well, let's see. Picture this. You're on a planet orbiting one of the stars in a quintuple system. It's a sunny day, and you're ready to hit the beach. As you step out of your space house, you look up at the sky and see not one, not two, but 5 suns shining bright like diamonds. 2 of them are super close together, almost as if they were one. Then you see the other pair, a bit further apart, each with their own glow. And finally, the loner star in the corner, just doing its own thing. It's overwhelming, to say the least. Now, you might be wondering, but what would the day-night cycle and changing of seasons look like on such a planet? Well, here things might get a little complicated. Depending on the orbits of the stars, the planet could experience pretty random daylight and darkness hours. They can even be constant or last for very long periods of time. All depends on the location of the planet. If we lived in a binary star system, things would be easier. There would be 2 distinct periods of day and night as the planet orbits around the 2 stars. But with 5 stars, their brightness and position would be constantly changing, so the day-night cycle could get extremely chaotic. Hey, I need my sleep here. On the other hand, this would make for some pretty spectacular views. We could experience several different sunrises and sunsets, each of different brightness and color per day. The changing of seasons doesn't get easier. You know how on Earth we have 4 seasons caused by the tilt of our planet's axis in relation to the Sun? Well, in a 5-star system, the locations of the stars could drive our planet insane. It's like having multiple chefs in the kitchen, all trying to cook different dishes at the same time. For example, if we're closer to star A, we experience more summer-like conditions. If we're closer to star B, things will be more chilly and wintry. And if we're located somewhere in the middle, we'll experience both summer and winter at the same time. It's like trying to juggle multiple balls at once. And this is a super simplified explanation. There are also things like the planet's orbital path, the tilt of its axis, the gravitational pull, yada yada. In short, the weather forecast will now become 10 times more unreliable. I'd hate to be the weather person on TV. That's a no-win scenario. And if that's not enough, then how about a roller coaster of radiation? The nasty solar winds and heat from multiple stars could make the conditions on our planet super harsh, rendering it uninhabitable. For example, if you're unlucky enough to live too close to the binary pair of stars, you'll feel like you're constantly stuck in a microwave. But hey, at least you wouldn't have to go to the tanning salon. And if you're too far away from the stars, it would be like living in an eternal winter wonderland. And if you're somewhere in the middle, well, imagine living in a place where you can get sunburn and frostbite on the same day. And this is just the beginning. You see, with 5 stars in the mix, there's a whole lot of gravity to go around. That's like being in a group hug with some really strong and clingy friends. The gravitational forces from the stars could tug and pull at the planet, creating tides so strong they could wash away entire cities. And don't even get me started on the earthquakes. With all that gravity, the ground beneath our feet would feel like it's constantly shaking, rattling, and rolling. On the bright side, though, at least we'd always have an excuse for being late to work. Sorry boss, I got caught in a gravity wave and ended up on the other side of the planet. You're not buying that, are you? As you can see, we'd have to try hard to adapt to such a system. All this, obviously, would create some challenges for agriculture. With multiple stars in the sky, plants would have to adapt to receiving light from different angles and intensities throughout the day. Farmers might need to create something to protect crops from excess heat and radiation. On the other hand, having multiple sources of energy from the stars is pretty awesome. Imagine fields of solar panels soaking up the rays from all 5 stars. But hey, maybe we would have been lucky and ended up on a planet where gravity and temperature changes wouldn't have bothered us so much. In that case, living in such a unique and inspiring environment doesn't sound too bad. It would have a great impact on our culture, arts, technology, and so on. With such a unique view of the cosmos, people would have a whole new canvas to work with. And just imagine, this isn't even the most complex of the systems we've discovered. For example, have you heard of AR Cassiopeia? It's a septuple star system, meaning it has 7 stars orbiting around each other. Now you might be thinking, wow, that must be a real chaos. And you're not wrong. Imagine trying to navigate a spaceship through all those gravitational fields. It's like playing a game of cosmic pinball. But all this serves as a reminder of the incredible diversity of the universe. Scientists continue to study and learn more about these rare and fascinating systems. And who knows what other mind-boggling star systems are out there, waiting to be discovered. Systems of 10, 15 stars. Nearly as many stars as there are in Hollywood. Get it? Stars, Hollywood? Okay, I agree, it's lame.
Solar activity is approaching its peak, and it might be as dangerous as it sounds. Scientists think it's likely to begin by the end of the year 2023, and that's years before it was predicted to start. From a distance, the sun seems to be calm and steady. But if you zoom in, you'll see that its surface is constantly seething and churning. It keeps transforming from a uniform ocean of fire to a chaos of warped plasma and back again in a repeating cycle. Every 11 years or so, the magnetic field of our star gets tangled up. Imagine a ball of tightly wound rubber bands. That's what it looks like at such moments. And then, at one point, it snaps and flips completely, turning the North Pole into the South Pole and vice versa. Right before this event, the sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emit powerful streams of radiation, and grow planet-sized spots. This period is known as solar maximum. It's a rather dangerous time for Earth since it gets regularly hit by solar storms. Such storms have the potential to disrupt communications and damage power infrastructure. Even worse, solar storms can harm astronauts working in space and even make satellites crash into the planet. At first, experts were sure that the current solar cycle would reach its peak in 2025. But judging by recent numerous sunspots, intense solar storms, and some other rare solar phenomena, solar maximum is likely to arrive as early as the end of this year. At the same time, most forecasts predict that the current cycle might peak in late 2024, and it's still 1 year earlier than NASA and NOAA had expected. During this maximum, around 185 sunspots will appear every month. But that's not too bad. Such a cycle is considered quite average compared to the historical record. The current cycle, which is the 25th since people started to record them in 1755, began in 2019 and was supposed to be really mild. You see, solar cycles vary in intensity. The weakest ones on record produced fewer than 100 spots per month during their peaks, and the strongest could produce more than 300. Why do the latest estimates differ so much from the initial ones, though? The thing is, it's still pretty difficult to forecast solar cycles. Plus, don't forget that we only have 25 cycles on record. It means the amount of data available for computer modeling is quite limited. These days, researchers explore alternative ways of predicting the behavior of the sun. They're based on the star's magnetic activity. Scientists have found out that the strength of every next solar cycle depends on the time when the magnetic field of the previous cycle vanishes completely. This event is known as the terminator. The terminator doesn't happen exactly at the solar minimum. No, it might still be up to 2 years till the next solar cycle starts to stir, waking up slowly. At the solar minimum, the magnetic field of our star is powerful and well organized. There are 2 distinct poles, like the ones a regular dipole magnet has. This magnetic field contains the sun's superheated plasma close to the surface, suppressing solar activity. But at one point, the magnetic field starts getting tangled again. Some regions become more magnetized than others. With time, the sun's magnetic field weakens. Solar activity starts to increase. Plasma rises from the surface of the star, forming giant magnetized coronal loops, peppering the sun's lower atmosphere. These horseshoe-shaped fiery ribbons then snap when the magnetic field realigns, releasing bright flashes of radiation and light. Those are solar flares. These flares often bring about huge magnetized clouds of fast-moving particles, coronal mass ejections. A few years after the solar maximum, the sun's magnetic field flips. That's the end of the solar cycle and the beginning of a new solar minimum.
Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter, and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star, it doesn't mean they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'd have a hard time without light and heat. So, how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable super-warm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they would all be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything, from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine, space is overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So, what would we eat? Well, we could use the same geothermal vents that we talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods, or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum! But besides food, we'd have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good, stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation. So, if you don't want to get crispy, you might want to invest in some serious SPF. So, how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem, finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Nyuk nyuk. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, who knows what kind of strange creatures might be lurking in those underground seas? But don't worry. Even if we don't have any underground oasis, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. And a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert, not exactly a sure thing. We may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there'll always be a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. Now, there may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating. And we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights, followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But, hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the rogue planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises. Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on… well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe someday we'll find such a planet and actually turn it into a bustling intergalactic metropolis someday. But until then, let's enjoy and tidy up our dear Earth.
Is it possible to put out the sun? For example, what would happen if we poured all of the Earth's oceans on it? Or even more water? Well, let's find out. The universe is a place full of mysteries. Since ancient times, scientists have been arguing about how space works. But none of us has ever doubted the existence of one thing: the sun. The center of our solar system. It's big, bright, and immortal? Nah, not really. Actually, the sun is just an ordinary star. It consists of 75% hydrogen, a little helium, and a pinch of other heavy elements. Gravity holds it all together. But in around 5 billion years, the life cycle of the sun will come to an end. The hydrogen inside it will run out. Our star will begin to grow gradually, and you can't even imagine just how big it will become. And then it will start eating all the nearby planets. That's when we'll regret being so close to it. After eating us all, the star will remain a red giant for another billion years or so. And then, sooner or later, it will begin to shrink and fade, turning into a white dwarf. In the end, nothing will remain of it but a bright and colorful planetary nebula. But don't get scared. Right now, the sun is in the middle of its life cycle. It was born about 4.5 billion years ago, and about the same amount of time remains. Fortunately, we were born during the star's best and most stable period. In other words, there's no reason to worry. So let's find one. How about speeding up the sun's life cycle with the help of water? We'll try to collect all the water on Earth and pour it onto the sun. First, we'll need a bucket. No, not this one. We'll need a really, really big bucket. The one that can contain around 326 million cubic miles of water. It will be equal in size to the distance from Washington to Chicago. Or if we can only find ordinary buckets, there should be around 70 quintillion of them. This is a number with 18 zeros. Okay, imagine that we magically got that many buckets. It's time to put out the sun. We splash the star with all this water and nothing? Seriously? Oh, just look at this. The sun has probably felt sorry for us and produced one little solar flare. It turns out that all water on Earth is actually just a pathetic drop for the sun. People often underestimate how much bigger the sun really is than our planet. In reality, it can fit more than 1,003,000 Earths. So yes, the sun won't go out or even get colder. It won't even notice that we've done something. But let's not give up. We really want the sun to go out for some reason. What happens if we pour just enough water on it? And how much is this enough? Remember our quintillions of buckets? Well, we actually need about 370 octillions of them. This number has 27 zeros. It's hard to even imagine, so let's just say that it's a lot of water. Now, let's splash it all over the sun again. Wow, just look at the steam! But the sun hasn't gone out again. On the contrary, it said thank you and suddenly became much bigger and brighter. What's happening? You see, the sun isn't actually a campfire. Inside bonfires, candle flames, there's a chemical combustion. When we pour water on the fire, the water absorbs the heat of the flame and cools it to such an extent that it can no longer maintain the burning reaction. It also blocks the fire's access to oxygen. Water basically stops the chemical process. But the burning of the sun isn't the same reaction. Even though we say it burns, it's not entirely true. What happens there is called nuclear fusion. It's one of the most violent and craziest reactions in the universe. There are many layers of hydrogen going deep into the sun. If you take 4 hydrogen atoms and ram them together, you're left with an atom of helium. When we talk about the sun, the process is a little more complicated. When the star tries to carry out that fusion, positive protons repel each other. It takes a lot of force and energy to somehow squeeze them together. Fortunately, there's a magical force in space. It's gravity. The sun takes up 99.8% of all the mass of the solar system. Pretty heavy, right? And all this mass is what holds the sun together with the help of an incredible gravitational force. So, gravity takes quadrillions of these little hydrogen atoms and pushes them together every second of every day. And when they collide, they release some energy. So, unlike fire, the sun doesn't need oxygen to live. It needs hydrogen. And we all know that water is H2O. It consists of hydrogen and oxygen. So this is literally fuel for the sun. It's like trying to put out a fire with gasoline. More importantly, the extra mass added by water will make the sun heavier. Now, gravity says, thank you for your help. And then it starts to collide protons with each other even faster. And thanks to this, the synthesis speeds up. Great, we've made the sun incredibly strong, and now it has eaten us, along with other nearby planets. And if we keep adding water, the sun will sooner or later collapse in on itself. It will blow off its outer layers and become a black hole. Awesome! Now it will pull inside absolutely everything around. Good job, guys. Let's press rewind because clearly our water experiment was a mistake. One small solar flare sounds much better. Alright, we're back to our usual calm sun. But it seems like there's something that we've forgotten. Well, apparently water was critically important for life on Earth. Who would have thought? Now there's a huge amount of unmoving fish and other marine creatures lying around where the oceans used to be. Poor things. As for deep-sea creatures, they simply didn't withstand such a sharp change in pressure. Algae and corals have also dried up. Wait a minute, weren't they responsible for producing 50 to 80% of the world's oxygen? Oops, it's time to put on some oxygen masks. And how are things on dry land? I mean, now everything is just land. But you get the point. Wow, this whole place is lit, and I mean it literally. If there are no oceans, then there are no clouds or rain. Now there are forest fires everywhere. Poor animals have to escape and leave their homes. Oh my. And it's not like they'll be able to find a new home, because all plants, of course, will dry up quickly. There will be literally no place for living left on the planet. So now Earth looks like a giant desert. Great! But people have been living in deserts for thousands of years, right? Maybe they'll know what to do. They won't. After all, people in the desert also need to drink. So now there's total chaos everywhere, and survivors fight for the last drops of water. If there are any survivors at all. In fact, no matter how much they fight for resources, their fate is sealed. The ocean absorbs a huge amount of CO2 and the heat coming from the sun. They also distribute this heat throughout the planet, making it pleasant to live on. But once they're gone, the temperatures will quickly jump to 250 degrees Fahrenheit and above. But even if we forget about the high temperatures, now we have no clouds, and they helped us too, by not letting through solar radiation. So we're also under the direct impact of the sun's rays. Our last hope is icebergs. Now that everything is terribly hot, they've melted. And maybe they'll be the last hope for humanity. But that cool solar flare was definitely worth it. Silly humans.
Hey, ready to test your knowledge? Of course you are. You'll get 1 point for each correct answer. So, without further ado, the sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you'll get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it'll look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they are the only ones that make it to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around a meteorite, they think it's super hot. Well, this is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, you know. But don't meteorites fall into the Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outside catches fire, but that layer is burned off on impact as a result of landing on Earth. As you would probably guess, when they land, the meteorites are lukewarm at most, but not as hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on. First the sun and now the moon. Am I living a lie? So, people look at the sky and see only the bright side of the moon. The reality is the Earth shines equally on all sides of the moon as it rotates and orbits the Earth. Half of the moon is in shadow, and half gets sunshine similar to Earth. That's not true. Similar to Earth, it doesn't have a permanent dark side. The logic is simple. The moon orbits Earth, but it also rotates on its own axis. When you think about it, we're always looking at the same side of the moon. Black holes take in everything that comes their way. What is it, myth or fact? Black holes don't have infinite mass and gravitational force, but still, no one really knows for sure what happens to the things pulled into them. Experts do know black holes do not have supergravity though. Let's imagine this. If there was a black hole as big as the Sun, it wouldn't immediately eat the whole planet. Imagine black holes as vacuum cleaners. It does draw in a cloud of dust near its range, but other specks of dust remain where they are. So even if there was a black hole replacing the Sun, all the planets would continue to orbit similarly. They wouldn't go into the black hole. If the star or something else got into the range of the black hole, only then would its gravity affect the star. When you call someone, the signal bounces off a satellite. Is this a myth or a fact? It's a myth. Or rather, an urban legend or misconception, you name it. I mean, there are some satellite phones, but we, regular people, don't use those every day. Although your mobile phone works in a much different way. When you call someone, the nearest tower connects you to the other person online. This is why there are tower connections, huge networks of tower-to-tower connections, and hidden cables. The moon has no gravity. Any guesses? Myth or fact? This is an urban legend. Ask any astronaut you know. If you don't know any, just trust me. There is footage proving that the moon has gravity. When I say the moon has gravity, don't think it's similar to the gravity on Earth that makes the apple fall. The moon's gravity is only about 1/6 of Earth's. How does it feel to walk on the surface of the moon? The second man on the moon, Buzz Aldrin, mentioned it's like moving in slow motion and, quote, perhaps not too far from a trampoline, but without the springiness and instability, end quote. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish, watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moonquakes. Does it sound like a myth or a fact? It's a fact. Quakes happen on the moon too, and they're called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super-Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the sun. Do you think this is a myth or a fact? This is a fact. Although the sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here, but it's only because it's so far away from Earth. All comets have tails. Myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? Shh, I knew it was too easy. This is a fact. Space doesn't have an atmosphere, so there's no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the Sun, so this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system and the second planet from the Sun. But the distance from the Sun isn't what defines the temperature. The heat depends on the atmosphere. So Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 degrees Fahrenheit. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The Sun rises in the west, and its rotation is very slow. Venus needs 225 Earth days to complete its spinning around the Sun. The planet's distance from the Sun affects the duration of one rotation. It's too close to the Sun, and the Sun has a strong, noticeable pull on the planets. Footprints on the Moon can stay there for millions of years. Do you think this is a fact or a myth? Fact checked. The Moon has no atmosphere, so there's no wind blowing, and without the wind, there's no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments.
The universe is expanding, and if it's expanding, then it probably had a beginning somewhere. Now, all we have to do is to run time backward and see where the beginning was. It took the scientists many more years to come up with a full-fledged theory, the Big Bang Theory. And here it is. Nothing has ever been anywhere, because neither when nor where existed. But actually, no. There was one thing. It was the so-called cosmic singularity, a state of our universe in which it was incredibly small, dense, and very, very hot. Imagine if our universe was compressed into a small ball. The pressure and temperature inside would be enormous. At some point, it became impossible to withstand them. And here comes the Big Bang. It was an outburst of energy and matter that created everything we see now. Time and space, basic physical forces. It also scattered quarks everywhere. These quarks, tiny particles that make up our world, were all boiling in an incredibly hot cosmic broth. When it cooled down, gravity began to attract them to each other. They gathered into atoms, then molecules, and then into the first objects in the world, stars. But what was before that? Alan Harvey Guth, an American theoretical physicist and cosmologist, has devoted his whole life to solving this mystery. After learning about the Big Bang Theory, Guth found some flaws in it. For example, the distribution of matter was very even, although it shouldn't have been. If we drop the balloon filled with paint down, it will burst. We'll see absolute chaos on the canvas. But the early universe don't look like. The early universe was very even and proportional. That was Guth's discovery, the theory of inflation. Here's what it says. Even before the Big Bang, there was some kind of force that could give the bang a strong acceleration, something that was able to distribute everything in space instantly and evenly. Martin Boyovald is a German professor of physics, and in his opinion, the universe was born quite differently. According to Martin's theory, the singularity couldn't just appear out of nowhere. Let's look at a pendulum on the old clock. The pendulum rotates back and forth. Its movement is smooth, continuous, and non-stop. This is how we usually see time. It flows and never stops. But quantum time doesn't work that way. It consists of small segments and makes short pauses. And just like with the second hand of a clock, the beginning of one segment of time is always the end of another. According to the Big Bang Theory, once upon a time, our universe began to expand, inflate like a balloon. But sooner or later, it will blow away back. The universe will start shrinking and return to the state of cosmic singularity. And then, the Big Bang too. Nothing appears out of nowhere and disappears into nowhere. According to Boyovald's theory, the beginning of each universe is the end of the previous one. Our universe is not at all the first and not the last. Millions of similar universes existed before us and will exist after us. This theory, although it sounds very logical, is far from complete. So for now, all this is just a hypothesis. But some people come up with even stranger ideas. Neil Turok, a South African physicist, and his colleague Paul Steinhardt, an American theoretical physicist. They say that yes, our universe isn't the first one. Our universe is just one of an infinite number of others. And all of us are stuck in a cycle of endless rebirths of parallel worlds. According to this theory, our universe is located inside a so-called brain, as in membrane. In other words, we're stuck in some kind of elastic surface that's capable of contracting, stretching, oscillating, and so on, like pieces of fabric on a rope. Another universe may be an inch from ours, but we can't see it. That's because there's a tiny space between us, and this tiny space contains the fourth dimension. How do these universes originate? Through brain collision. These brains are getting closer to each other very, very slowly, until they finally collide. Their collision creates two Big Bangs and two parallel universes. Then they're moving away from each other. The created worlds continue to live. We're currently at this stage. Remember the inflation theory? There was a mysterious energy that pushed and accelerated the Big Bang. Well, if we did collide with another universe, that would explain everything. Which idea is closer to you? How about the idea of subscribing? Subscribe. The main question of all time goes like this. What was there before the Big Bang? The most common theory claims that about 13.7 billion years ago, before this incredible rapid expansion occurred, the universe existed as a singularity. It was a point tinier than a subatomic particle. At least, that's what the Big Bang theory tells us. Okay, but what was before that? This question has been bothering the minds of the greatest cosmologists for at least 1,600 years. For example, 4th century theologian St. Augustine was trying to figure out the answer to the question of what had existed before the universe was created. He made a conclusion that the phrase, "in the beginning," mentioned in the Bible, implied that nothing had existed before that. He also believed that time and the universe had been created simultaneously. The ancient Greeks were also bothered by the same question and kept debating the origin of time. Philosopher and scientist Aristotle, for instance, took the no-beginning side. He thought that nothing could come out of nothing. In other words, to get a universe, you need to have something for this universe to appear from. And since the universe couldn't have gone from nothingness to somethingness, it must have existed forever. That's why time must stretch eternally into the past and future. In the early 20th century, the world got to know about Albert Einstein's theory of general relativity. According to this theory, mass warps time, making it run a bit more slowly for, let's say, a human standing on Earth's surface and a satellite orbiting our planet. Based on Einstein's work, other ideas started to pop up, including the one that stated that the universe started as a singularity and expanded through the Big Bang. Then, quantum physics came into play. It gave birth to a bunch of new theories, which brought forth the questions about the pre-Big Bang universe again. And aren't these ideas fascinating? Some researchers believe that our universe is just an offspring of another much older universe. According to them, the evidence for this theory can be found in the cosmic microwave background, CMB, which is the relic radiation left over from the Big Bang. But let me explain. For the first time, astronomers observed the cosmic microwave background in 1965. At that time, they didn't know it would soon create problems for the Big Bang theory, challenging its ideas and postulates. Now, according to the inflation theory, an extremely rapid expansion of the universe occurred in the very first moments of its existence. This theory accounts for the changes in temperature and density in the CMB. It also claims that these fluctuations should be uniform. But recent mapping results show that the universe is actually lopsided. More fluctuations occur in some areas than in others. This makes some scientists believe that our universe bubbled off a parent universe. There's also a chaotic inflation theory, which takes this concept even further. It believes in an endless progression of bubbles, each eventually becoming a universe. And each of these appearing universes gives birth to even more bubbles, which results in an immeasurable multiverse. There are other models too. Some of them revolve around the pre-Big Bang singularity and black holes. If we think of these space monsters as cosmic trash compactors, they might end up being the main candidates for primordial compression. And our rapidly expanding universe could be a white hole output from a black hole dwelling in another universe. A white hole is a hypothetical object that acts in the opposite way to a black hole. Instead of pulling everything inside, it constantly gives off energy and matter. There's also the Big Bounce theory. Its main idea is that instead of going through one Big Bang, the universe expands and contracts in a cycle, bouncing back every time it shrinks to a certain size. Each cycle, therefore, begins with a tiny, smooth universe that gradually grows, becoming more warped with time. And eventually, it starts to collapse, smoothing itself out before starting anew. If you liked or disliked our video, put a like or dislikes. Leave comments. Let's discuss the mysteries of the universe together. And now don't leave, the video will continue. Have you heard of quantum immortality? These days, many people are confused about this notion. But if you believe in it, you also believe that you can live forever. How come? Well, quantum immortality claims that nobody ever disappears forever, and that consciousness never passes away. Instead, once you cease to exist in one universe, your consciousness simply gets transferred to a parallel universe, and there, you survive. This idea sounds more like a sci-fi movie than something that real science can suggest. It could be a script for a blockbuster. People's consciousness can transfer from one world, where an apocalyptic event has wiped out all life, to another, where such an event has never occurred. And the only clues about the slight differences between these worlds are a few Mandela effects. This phenomenon is named after people disremembering Nelson Mandela's passing. These days, the term is used to refer to any collective false memories. So maybe in that new world, millions of people will be wondering, since when has Pizza Hut been written with 2 T's? But the thing is, in this new reality, this popular brand name has always had 2 of them. Imagine going through apocalypse after apocalypse, transferring to one world after another. It might be a nice, if a bit horrifying, thought that you're going to live forever. Instead of passing away completely, you'll just keep transferring to a universe where nothing tragic has happened to you. But is there anything to this theory? What does science think about such a possibility? In fact, the idea of quantum immortality has been around for quite some time. It has been seen both as untestable nonsense and as a curious thought experiment, like the one involving a cat. And here, I mean Schrödinger's cat. Let me explain. According to one of the interpretations of quantum mechanics, particles can exist in several states at the same time. But when a particle is being observed or measured, this system collapses. As a result, the particle is found in just one of its possible states. In 1933, Schrödinger suggested doing a certain thought experiment. He believed it would show the absurdity of this idea. In his hypothetical scenario, a cat was placed inside a box with radioactive materials. These substances had a 50-50 chance of decaying over an hour. If it happened, the radioactivity would be detected by a Geiger counter, which, in this case, would smash a vial with poison. As you might assume, it wouldn't end well for the cat. Schrödinger saw the following problem. The cat in the box would be both alive and not alive at the same time. The animal would be in this state for an hour, until someone opened the box and checked on the feline, either lifeless or very annoyed. One solution to this problem, known as the many worlds interpretation, gets around this situation by claiming that both outcomes take place. According to this hypothesis, all possible outcomes of quantum measurements occur across many universes, and their number might be infinite. It probably doesn't come as a surprise that this theory is often criticized. Many mention that this idea is unfalsifiable, since universes don't interact with one another, making the theory impossible to test. It's even been called one of the most implausible and unrealistic ideas ever. After all, it's not clear why your consciousness would get transferred between worlds just because you cease to exist in one of them. Unless it's a thought experiment, of course. It might provide you with the comfort of knowing that there is another you who doesn't pass away in a different world. But why should you believe that you only exist in the world where you're alive? What about the universe where you didn't make it? Like, what happens to your body? And speaking of the suggestion that you might understand that you're in a different universe thanks to Mandela effects, it's kind of the area of science fiction. Throughout the years, scientists have made some discoveries that seem to hint at the existence of extraterrestrial life. But do they really? Let's find out. In 1976, NASA's Viking Mars landers detected chemical signatures that could be a sign of extraterrestrial life. During one of the experiments, Martian soil was mixed with special nutrients and then tested for the production of methane gas, and the test's result was positive. In other words, something in the soil was metabolizing these nutrients and producing the gas. Unfortunately, other experiments conducted on board the landers didn't show any evidence of life. It caused NASA to declare the result a false positive. And still, some scientists keep standing by the finding, arguing that the experiments on board were ill-equipped to look for a key indicator of life, organic molecules. In 1977, an Ohio State University radio telescope detected a bizarre pulse of radiation coming from someplace near the Sagittarius constellation. It lasted 37 seconds and was so unexpected that the astronomer who was monitoring the data at that moment scribbled, "Wow," on the telescope's printout. The thing is that the radio frequency of the signal is internationally banned on Earth. The signal could be the result of a supermassive astronomical event, or it could be sent by some kind of intelligent life with immensely powerful transmitters. So far, this mystery has remained unexplained. In 1996, NASA scientists announced that they had found something that could be microbes in a potato-shaped chunk of Martian rock. The meteorite might have been blasted off the surface of Mars in a collision. It had been wandering the solar system for about 15 million years before it fell in Antarctica. Analyses showed that the meteorite contained some organic molecules and tiny particles of the mineral called magnetite. It's sometimes found in bacteria living on our planet. NASA researchers used an electron microscope and announced that they had spotted nanobacteria. But since that time, this evidence has been called into question a few times. Some experts say that the particles of magnitude are not really similar to those found on our planet, and Earth's contaminants are likely to be the source of organic molecules. Jupiter's moon Europa has a bizarre red tinge. Some of the theories explaining this phenomenon have suggested the reason is frozen bits of bacteria, which are also responsible for the mysterious infrared signal the moon gives off. But this theory hasn't been proven yet. The existence of life in Venus's clouds might explain curious anomalies in the composition of the planet's atmosphere. Solar radiation and lightning are supposed to generate tons of carbon monoxide on Venus, but in reality, this gas is rare, as if something is removing it. Another weird thing is the presence of both hydrogen sulfide and sulfur dioxide in the atmosphere. Usually, these two readily react together. That's why it's rare to find them coexisting. The only explanation can be that some process keeps churning them out. But probably the most mysterious is the presence of carbonyl sulfide. The thing is, on Earth, it's only produced by microbes and not by some inorganic process. Some experts believe that microbes might be living in the atmosphere of Venus. The surface of the planet, scorching hot and acidic, isn't very suitable for the development of life, but up in the atmosphere it's moist and hospitable, with a pressure similar to Earth and pleasant temperatures. But again, we haven't received any solid proof yet. In 2003, scientists discussed the possibility that the traces of sulfur on Jupiter's moon Europa could be the waste products of colonies of underground bacteria. The compounds were first discovered by the Galileo space probe, which also found some evidence of a volcanically warmed ocean beneath the icy crust of the moon. The sulfur signatures look similar to the waste products of bacteria living in the surface ice covering lakes in Antarctica on Earth. But other scientists rejected the idea. They argued that the sulfur could have come from the neighboring moon. Io there, it's found in abundance.
Now, did you know that our sun is actually green? Okay, I'm kidding. But in reality, it's all colors you can imagine at the same time. Wait, what? I know it sounds like a joke, but I'm being serious, can't you tell? In fact, our sun contains absolutely all the waves of the light spectrum. It's simultaneously red, blue, green, yellow, you name it. Where do you think rainbows come from? When sunlight gets reflected off water droplets in the air, it splits into a bunch of colored waves that we can see individually. And when they're all together, we see a white ray of light. Our eyes are unable to perceive the concept of all colors at the same time, so their combination seems white to us. Wait, you might say, why white? Isn't the sun yellow? Yep, it's yellow too, but please don't stare at the sun just to make sure. It appears white when we see it from the International Space Station. This is the sun's real color as our eyes perceive it. The sun gets a yellowish hue when its rays get scattered in Earth's atmosphere. Our atmosphere doesn't let the blue rays of the spectrum pass very well, but the red ones? Hey, sure, why not? By the way, that's why the sky seems blue to us. The atmosphere scatters the blue color all over the place. During sunrise and sunset, short blue waves get reflected, but the long red ones reach us perfectly. That's why we see sunsets as pink, orange, or red. But what would happen if the sun had a different color? To answer this question, let's quickly repeat what we've learned. 1. The sun has the whole color spectrum in it. 2. Our atmosphere is like blue rays? Nope. Red rays? Anytime. So you probably already guessed what would happen if the sun was, let's say, red. The whole world would look like it does during sunsets. Not bad, huh? We wouldn't even have to wait for the evening to admire the scarlet sky. Orange water and a bright red moon. Yeah, it would be darker than what we're used to, but still not bad. Oh, by the way, one day, the sun will actually turn red. When its life comes to an end, it will expand and gradually turn into a red giant before finally burning out. But it's not going to be so much fun for us. So let's hope we won't be around to see that moment. I know I won't. Hey, I've got a party to go to. Okay, now, what if the sun was green? Well, the truth is, the sun is green. So here's your dialogue.
Wait, are you kidding me? Didn't you just say that it's white?
Ooh, good job on that, by the way. Well, not exactly, bud. The sun just looks white, but technically, it has a temperature of around 10,000 degrees Fahrenheit, and the pink wavelength of the sun's spectrum corresponds to the green-blue hue. But to make sure that the sun is green, we need to drown out the rest of the visible spectrum. Then our atmosphere will let through a pure green color. And what'll happen then? Well, everything will be green, and everything will also be a bit darker. Well, face it, it's not easy being green. Okay, moving on. Now let's paint the sun blue. Blue stars actually do exist. They're called blue giants. Fortunately, our sun is not one of them. Why fortunately? Well, because if it was a blue giant, it would be a young, beautiful, unimaginably large, and very, very hot star. See, our red is hot, blue is cold logic doesn't apply to stars. The hottest stars are white and blue, and the coldest are yellow and red. Yeah, our sun is actually very cold compared to other stars. Now, take the average temperature in your city, but multiply it by hundreds of thousands. Yeah, we're struggling with global warming here, but global burning? No thanks, blue giants. Anyway, let's imagine that the sun turned blue. How would we see the world? Surprisingly, nothing would change. Remember how I said that the atmosphere scatters blue light? That's why, in this case, everything would remain almost the same. Maybe the sky would get bluer, but we wouldn't see much difference. And finally, the darkest, pun intended, option. What if our sun turned black? Stock up on lamps and candles because there is no more light. People use electricity all over the world 24/7. We also can't see the moon anymore. After all, we can observe it these days only because the sun's rays get reflected off of it. Now, the only thing we still have to illuminate our nights are stars, but they don't help us much. Good thing this scenario is totally unrealistic and there are no black stars, right? Well, yeah, there are no black stars, and still our sun will eventually become completely black one day. And I don't mean a black hole. I'm talking about black dwarfs here. You've probably heard of white dwarfs, maybe even seven dwarfs. When a star like our sun is about to finish its life, it expands and turns into a red giant. And then, gradually losing its upper layers, it turns into white dwarfs. Since they no longer produce fuel, they slowly cool down. All that remains is a small core, living out its life and burning bright. And when the star cools down completely, it turns into a black dwarf. But you've probably never heard of them. Why? Because, surprise, surprise, they don't exist. And no, I was not lying. The thing is, a star needs about 1 quadrillion years to turn into a black dwarf. And our universe is still a baby. It's only about 14 billion years old. So no star has reached this stage yet. Even the most ancient of them still emit a little light. That's why black stars are just a theory. And it's unlikely that we'll ever see such a star at all. But remember the famous saying, the stars that we see at night are already ghosts because their light has reached us only now. Well, that's a myth. They're all still alive. Why am I telling you all this? Well, let's imagine that our sun turned into a black dwarf. The entire solar system would immediately get plunged into absolute darkness. It would also be terribly cold. The moon would leave its orbit and crash into Earth. Wait, no. Let's overlook this moment and assume we're still alive. Fortunately, we wouldn't freeze instantly, as you might think. Earth's core has its own temperature, more than 9,000 degrees. But the temperatures on the surface of the planet would still immediately drop to 32 degrees Fahrenheit. The core would gradually cool down. Every 2 months, its temperature would drop by 2 times. In just 2 months, Earth's surface temperature would be minus 190 degrees, and in a year, it would reach minus 450 degrees. Most plants would disappear pretty quickly, not because of the cold, but because of the lack of photosynthesis. Others would live a little longer thanks to the oxygen still remaining in the atmosphere. And, oddly enough, trees would survive for a very long time. They have a slow metabolism and get sugar from the ground. The upper layer of the oceans would freeze very quickly. Fortunately, this thick crust of ice would insulate deep waters, so the entire ocean wouldn't freeze for some time. Marine creatures would be doing pretty well. They existed long before us and are already used to crazy temperature changes, the lack of oxygen and food, huge pressures, and other joys of deep-sea life. And what about us humans? Well, first of all, we'd start getting sick. Without vitamin D, people would face a huge number of different health problems. Also, our bodies need sunlight to produce melatonin. This melatonin helps us understand when we should go to bed and wake up. If people didn't have this hormone, their bodies would get very confused and wouldn't understand whether they needed to sleep or not. That would mean insomnia for many people. But we would still be able to survive. We'd have 2 options: to build giant submarines and go down into the depths of the ocean closer to Earth's core, or stay on the surface, living our lives in some location where we'd have sources of geothermal energy. In Iceland, for example. We could also settle near volcanoes. Their heat would be enough to warm us for a long time. Our vision would adapt to the dark, but at some point it would reach its maximum. So we'd need to get used to living in complete darkness. But who knows? Maybe we would adapt to this life too. So, which option would you prefer? Living at the bottom of the ocean in a submarine or on the surface near volcanoes? So, what's going on with all the news about the sun? Some say that the sun is getting angry. Well, what does that mean exactly, and should we be concerned? Frankly, yes, we should be concerned. It's generally not a good thing to get too much sunshine. The ultraviolet component of sunlight is harmful to the skin. That's why humans have adapted a spectrum of skin pigmentation. The more sunlight there is to protect ourselves against, the more pigmentation we need. Big floppy hats, and of course, bottles of high SPF oil-free sunscreen help too, especially for fair-skinned people. But what is planet Earth going to do? First, let's get a good estimate of just how angry the sun is likely to get. The sun usually goes through an active-calm-active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Brightsiders about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the sun gives off. Thankfully, the amount of visible light the sun gives off doesn't change very much. That would be a serious problem. If the sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the sun is. The more sunspots that are visible, the more active the sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm, like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years. In early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the sun. High-speed electromagnetic plasma gas from the sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the sun, but they aren't dark. They're just not as bright as the surface of the sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the sun associated with sunspots. As the superhot plasma gas on the sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, a powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the North and South Pole areas on Earth, while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the sun's surface. The corona of the sun is much hotter than the surface of the sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the sun. Cool, huh? Turns out the sun is ringing or oscillating like a bell. And we have 5 observation sites across the globe. One in India, Australia, one in the Canary Islands, one in Chile, and one in California, that keep a constant watch over the 10 million sound waves moving on and around the sun. Now that the sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the Sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the Sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the Sun is a bit concerning when trying to predict how active the Sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the Sun. It is as if the magnetic distortions we usually see on the photosphere of the Sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this magnitude in the near future? Well, stay sharp, Brightsiders.
Is it possible for a planet to have not one, not two, but many suns? Let's imagine what would happen to us if the Sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sunsets. Scientists even suggest that our Sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So they turned to the stars to find out what the reason might be. And then they assumed that it was a star that left our Sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's going to be a fun car trip, 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's going to be as chaotic as can be. In stellar mechanics, it's called the three-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how three stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who'll have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe. So, they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Scholz bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. They won't be stable anymore due to the regular changes in gravitation. In other words, You'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between two stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our four suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of two stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri b. That's a planet near the closest star system to our sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns.
Now, as much as we love epic space battles with blasters cutting through the black void and causing cheerful booms, that's not exactly what happens when something explodes in the big black. Space is basically vacuum, meaning it has no oxygen. And oxygen is an essential part of any process of burning we have here on Earth. You might argue that stars can burn and explode into supernova, but that's not exactly true either. Stars don't rely on oxygen, so they're not burning. There are constant thermonuclear reactions going on inside them. So a spaceship can only explode like that if it has a nuclear power plant installed in it. If it doesn't, then the only special effect you get is a brief flash that disappears in the blink of an eye. Liquid oxygen, which is often on board spaceships, is very quick to burn out in the vacuum of outer space. As for the boom, oxygen plays a crucial role here too. Sound only travels thanks to molecules of air bumping into each other. Since there's no air in space, the whole scene would be pretty much absolutely silent. And that's not a bad thing either. Just imagine how deafening would the sun be if the sound could travel in space. Despite what many sci-fi directors want us to believe, there's no dark side to the moon. Our satellite is tidally locked with Earth, meaning it's always turned to us with one side, while the other always looks away. The sun is much farther from us than the moon, and we're both turning round and round, warming and lighting this side and that in turn. It means that once in every short while, the moon is lit by the sun from either side. It's just that we can't see it from where we are. While things appear weightless in outer space, there's actual gravity all over the place. It becomes weaker the further you get from a heavy object, like our planet, but it's still there. In fact, there's not a single place in the universe that isn't affected by gravity of this or that cosmic object. Everything that has mass has gravity as well. Yes, even you and me. But space objects are so massive that they tug smaller things towards them. That's why the planets of the solar system orbit around the sun, and our whole Milky Way galaxy orbits around its own center. Scientists believe there's a supermassive black hole there, about 4 million times heavier than the sun, which keeps all the stars and systems from flying apart. Our movie hero leaves the orbit of Mars on their trusty spaceship and heads on towards Jupiter. Their face is grim and determined, even though they know what threat awaits them ahead – the asteroid belt. They pitch and yaw, dodging the asteroid flying at enormous speeds toward the spacecraft, but one of them still hits it. No, just a scratch, thankfully. Finally, our hero leaves the danger zone and wipes the sweat from the brow with a shaking hand. Sounds familiar, but couldn't be further from the truth. Asteroids in the belt between Mars and Jupiter are so few and far between that if you ever travel through it, you might not even encounter one the whole way. There are about 1.5 million sizable space rocks flying there, give or take 500,000. But let's not forget, space is a vast place. The distance between two asteroids of any significant size would be millions of miles. So a space chase with two ships weaving between floating rocks would be quite boring in there. Space is often depicted as a black, cold, and desolate place, especially when a movie astronaut leaves the safety of their spaceship. Everything about this description is okay, except for the cold part. It's only true if you find yourself in some really far corner of our galaxy that has no nearby stars. But if you're, for example, in the Earth's orbit and directly facing the Sun, the temperature in the cosmic vacuum could reach a scorching 250 degrees. That's why spacesuits are white. This color reflects light better than any other. Still, the temperature at your back, which isn't exposed to the sun's rays, can be really freezing indeed. Heat doesn't spread equally through space, so if you're not turned towards a heat source, you get very, very cold. Speaking about the sun, it somehow always appears yellow in movies. The fact is, the color we see from Earth is an optical illusion created by our planet's atmosphere, just as the blue sky during the day. The light from the sun spreads in the atmosphere and gets distorted, making colorful spectacles at dawn and dusk. In the vacuum of space, there's nothing to reflect the light, so the sun appears as it really is, white. That ball of glowing gas is that hot. There's a bright flash in the sky, followed by a tail of smoke, and a red-hot space rock crashes into the ground, leaving a huge charred crater after impact. Well, although the smoky tail and the crater are partly true, meteorites don't really have a chance to become that hot while falling. Meteorite is an asteroid that somehow entered the Earth's atmosphere and survived the friction enough to fall on the surface. This happens pretty often. We just don't usually see those rocks because they're normally quite small and fall into uninhabited areas. But even if one falls within a city, the crater would appear because of the sheer speed of the meteorite, not its heat. They do get much hotter because of friction, yet not so much as to burn everything on the ground on impact. As much as we want to believe in instant communication between spaceships and planets, it's not possible, at least not yet. Modern communication systems rely on radio signals that have a pretty slow speed compared to the vast expanses of space. It would take years for such a signal to travel even 1 light year, let alone hundreds and thousands. If you want to send a message to a galaxy far, far away, be prepared to wait a couple of millennia and then a couple more to receive a reply. On that note, space is not as crowded and full of events as is often shown on the silver screen. It's mostly a rather lonely place where planets, stars, and other objects are separated by billions of miles of nothingness. Even if you have a spaceship that can travel at the speed of light, most of the time you'll only see black void full of stars and planets far away. The distances are enormous out there, even between the closest objects. For a better understanding, the Moon, which you can see so well on a clear night, is about 239,000 miles away. It's like traveling around the Earth almost 10 times in a row. Warp drives that can distort space-time and get you to a distant corner of an alien galaxy in the blink of an eye, that's a staple of any space opera. Spaceships capable of such a feat are always shown as instantly accelerating from zero to faster than light. According to the law of physics, people on board should, well, at least be pushed into their seats hard. More strictly speaking, no one would be able to survive such an acceleration because it's too many G's on a fragile human body. Until we find a way to reduce the effects of overload, we can't even start thinking of space warps. Water isn't the rarest and most precious resource in the universe. In fact, there's a humongous space cloud several million light-years away from us that consists entirely of water. Its reserves would be enough to fill all our oceans 140 trillion times over. And many planets, some even in our solar system, seem to have liquid water on them. The most precious resource in space is life, and that requires a lot more stuff to appear than just liquid water. Astronauts are often shown working out on the ISS and sci-fi space stations, and that much is true, they do need physical activity. But the reason isn't that they need strong bodies to work in space. The gravity out there is much weaker, and astronauts don't use their muscles as much as on Earth. So when they come back to the surface, gravity hits them as a sledgehammer, and their bodies feel squishy. To alleviate those effects, they train every day. Although they say we can see millions of stars on a clear starry night, that number is much more modest, about 3,000. All the rest are other objects that are also luminous and mistaken for stars: planets, distant galaxies, and even artificial satellites. They're simply being illuminated by real stars, just like the moon, and become seen. But because they're that far away, we can't tell if they're stars or not. Still, you gotta admit, it's all still pretty cool.
In July, when we're about 94 million miles from the Sun, the world is about 36 degrees Fahrenheit warmer overall than in January, when we're 3 million miles closer. This is because there's more dry land in the northern half of the planet than the southern half, and land tends to heat up more than water. During the northern summer in July, more land is heated up than in January. So the planet gets a little warmer at this time, even though we're further from our source of heat. The closer the moon is to the horizon, the larger it looks. This phenomenon is called the moon illusion. One of the theories explaining it claims that the atmosphere plays the role of a magnifying glass, which makes the moon look bigger. In reality, if the atmosphere had a say in it, the moon would actually look smaller, not bigger. Most experts believe that the illusion is created by your own mind. It can increase the moon's size more than twice. When Earth's satellite is high up in the sky, you don't have any visual cues about how far away it is. But when it's near the horizon, you can see objects surrounding it in detail. It makes the moon look larger. But it's just one of the many theories explaining the phenomenon. By the way, you can trick yourself out of this illusion if you bend down and look at the moon upside down through your legs. A day on Venus is longer than a year. It takes the planet 243 Earth days to rotate around itself, and only 225 Earth days to make a full circle around the Sun. Around 5 million years ago, the supermassive black hole at the center of our galaxy launched a star from itself, and it's now traveling through the Milky Way 10 times faster than any other star out there. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface showing that it's getting smaller. After more research, they found out that Mercury hasn't finished cooling down yet. The Earth and the Moon are gradually drifting apart, as slowly as your fingernails grow. This is the flip side of our satellite's gravitational force. The Moon creates tides in the Earth's oceans. They pull back at the Moon and make it speed up. This in turn moves the satellite to a higher orbit. In prehistoric times, the Moon was way closer to our planet than it is now. Luckily, we aren't going to lose the Moon. The farther away it moves, the weaker its gravitational pull becomes. It means that soon, our planet won't be pushing the Moon away with such a force. Discovered in 2017, Kelt 9b is the hottest planet we know of. Next time you're complaining about the heat on a scorching summer day, just remember that temperatures on this planet can reach 7,800 degrees Fahrenheit. That's because it orbits really close to its star, which is called Kelt 9. This thing is way hotter and bigger than our Sun. Experts believe that the giant star might someday evaporate the entire planet with its intense heat. Kind of a sizzling solar sauna, wouldn't you say? Everything on Earth, and everything people have managed to see in space with the help of telescopes and other instruments, is normal matter. It's made up of atoms and molecules, and adds up to less than 5% of the universe. Almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if several decades ago they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite, it was accelerating. It meant there had to be some enigmatic force that counteracted gravity. It got dubbed dark energy. Cold welding is a phenomenon in space when two pieces of the same metal join together without any trouble and heat. About 700 million years ago, a mysterious event that occurred may have turned Venus into the place it is now. Admittedly, astronomers can't see the surface of the planet directly because it's covered with dense layers of thick clouds. But space missions that have been sent to the hot planet found that Venus is peppered with fire-breathing volcanoes, massive mountains, countless craters, and gigantic lava plains. The temperatures on the planet are so incredibly high that they could melt lead, and the atmospheric pressure is so immense that it would instantly crush any living being reckless enough to set foot on it. If that's not enough, the atmosphere of the planet is filled with noxious clouds of sulfuric acid, which smells worse than rotten eggs. Carbon dioxide, the main component of Venus's atmosphere, along with the infamous sulfuric acid, create a powerful greenhouse effect. As a result, the lower atmosphere and the surface of the planet are some of the hottest places in the whole solar system. Neutron stars are the size of a small city, yet their mass is about 1.4 times that of the Sun. They're formed when massive stars die and their cores collapse in on themselves. The core continues to press in on itself until all the electrons are essentially crushed together, leaving only neutrons. This makes neutron stars one of the densest objects in the universe. In fact, a single teaspoon of neutron star material would weigh 1 billion tons. Of course, getting this sample and delivering it back to Earth might be a difficult task, since the gravity on a neutron star is 2 billion times stronger than the gravity on our planet. Because of the effect the moon has on Earth, our planet is gradually rotating slower and slower, and I mean very gradually, at around 17 milliseconds every 100 years. So, it will take 140 million years before the world can add a single extra hour to its day. But that also means that when the dinosaurs existed, there were only 23 hours in a day. There's very little activity going on inside the moon. Plus, there's almost no atmosphere around. That's why scientists can trace impact craters littering the satellite's surface back billions of years. While dating the craters, astronomers discovered that the moon, along with our planet, went through a late heavy bombardment about 4 billion years ago. This event is also known as the lunar cataclysm. This interval lasted several 100 million years. During it, an unusually large number of asteroids collided with Earth, Mercury, Mars, and Venus. The newest scientific theory claims that Venus could have had a pleasant, stable climate for billions of years before something went wrong. Astronomers did thorough research and built a model of a virtualized Venus-like world. This model demonstrated that for most of its history, the hot planet had oceans with liquid water, adequate temperatures, and stable tectonic plates. In fact, the planet resembled Earth as it used to be at the beginning of its life. Scientists suppose that this period of Earth-like development could have lasted for more than 3 billion years. Saturn is a planet with winds that travel at more than 1,100 miles per hour at the equator. It's also the planet with the most prominent rings. The atmosphere of Saturn isn't really different from its surface, but the deeper you go, the higher the pressure becomes, and hydrogen becomes liquid. Further to the center of the planet, this liquefied gas turns into metallic hydrogen. Like Jupiter, Saturn might have a rocky core, with hydrogen and helium surrounding it. On the other hand, even if it is made up of rocky material, the core can still be liquid. Humans have been exploring space for over 60 years, and the effort has certainly paid off. All the planets in our solar system have now been explored, even the dwarf planets of Pluto and Ceres. Most of the exploration was done by NASA's Voyager program, which began in 1977. Voyager 1 and 2 collected information on the planets, their moons, and their unique systems of rings and magnetic fields. These twin spacecraft continue to send data back to Earth, and Voyager 1 is currently in interstellar space. The sky might appear pretty peaceful as you look at it from Earth, but the Milky Way is headed for a massive collision with the Andromeda Galaxy. 4 billion years from now, you can set your alarm. These galaxies will meet, and neither will survive. Stars will be scrambled, and constellations will be undone. Eventually, the two giants will merge and form an elliptical galaxy. But according to National Geographic, our Sun and Earth will survive. Any life forms on Earth will be treated to a splendid sight as the galaxies come together.
Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system that we haven't yet discovered. We've been looking for it for years, but finally, it seems like scientists found a key to solve this mystery. Planet 9 is a hypothetical planet. Astronomers have been on the hunt for it for quite some time now. But it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, hanging out somewhere between Neptune and Pluto. Some scientists think that Planet 9 might actually be a mini Neptune, with a thick, gaseous atmosphere and a rocky core. Others speculate that it could be an icy world with a solid, frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure that it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole or made entirely of dark matter. The search for Planet 9 began in the early 21st century when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper Belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might be a fluke. But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat disk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval, rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot, so the only way we may discover it is by studying the gravitational effects it has on our solar system. And this isn't the first time astronomers have gone looking for a new planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in the laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even supposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan from Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper Belt and the rock-filled Oort cloud, where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs as large as almost 90 miles across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean, they're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments like modern telescopes. Talk about cool friends to have, right? Sure, the process of finding it may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper Belt, and beyond. As we've already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. If this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So, grab your telescopes and let's go planet hunting. Who knows, maybe we'll find it sooner than we think.
Let's see, there's Mercury, Venus, Earth, Mars, Phaeton, Jupiter. Wait, hold on. What Phaeton am I talking about? Well, let's see. It was the beginning of the 19th century, and the asteroid belt hadn't been discovered yet. In the year 1801, one man named Giuseppe Piazzi spotted the largest asteroid in the solar system, Ceres. At that time, people believed that there was a planet orbiting between Mars and Jupiter, and Ceres seemed to fit the bill. But the next year, another astronomer, Heinrich Olbers, found one more space body following a similar orbit. It was an asteroid which was later called Pallas. This discovery helped Olbers to figure out that these two space objects could be fragments of a planet. The discovery of two more asteroids, Vesta and Juno, seemed to confirm this theory. It was believed that the planet, which was named Phaeton in the 20th century, appeared in the early days of the solar system and was later destroyed, and its debris formed the asteroid belt. Olbers' idea was called the disruption theory. To astronomers at that time, it seemed obvious that the planet once collided with a large space object, which led to its demise. The most likely candidate was Nemesis, a hypothetical red or brown dwarf orbiting our Sun. Another theory claimed that Phaeton could have gone through an internal cataclysm, which could have broken the planet into pieces. There was one more idea. Phaeton could have come too close to Jupiter and got torn apart by the gas giant's immense gravity. These days, though, astronomers don't believe in the disruption theory anymore. A new idea has replaced it. It's known as the accretion theory. It claims that the asteroid belt is all that is left of the protoplanetary disk. Supposedly, this disk had been originally orbiting the Sun, even before the planets formed. Unfortunately, because of Jupiter's gravitational forces, it never managed to coalesce into a planet. But what is this asteroid belt we keep talking about? This region is located between the orbits of Jupiter and Mars. Tons of asteroids and even minor planets are found there. Some of them can sometimes migrate or even get thrown out of the asteroid belt to the outer solar system. The four largest asteroids in that area are Ceres, Vesta, Pallas, and Hygeia. They make up half the mass of the entire belt. As for the rest of the mass, countless smaller bodies make up for it. In loads of sci-fi movies about space, the main character gets into an asteroid belt and has to try hard to get away from countless rocks threatening to smash their spacecraft. Well, it has nothing to do with the real thing. Even though there are thousands of asteroids in this region, they're so widely spaced that the chance of collision is next to nothing. Hey, but it's a movie, right? Anyway, when the asteroid belt was forming, some objects started to come together and form what we know as protoplanets. But the gravitational pull that was caused by the formation of Jupiter made such collisions too rough, and instead of forming large space bodies like planets, asteroids shuddered. Astronomers think that as a result of such collisions, more than 99.99% of the original mass of the asteroid belt was lost in the first 100 million years of the history of the solar system. Only the largest asteroids have enough gravity to get a spherical shape. Small ones are just often piles of rubble, loosely held together by gravity. And the tiniest objects in the asteroid belt resemble dust, so small they are. And all these objects, giant and tiny, orbit the Sun. There are several types of asteroids, depending on their composition and albedo, which is the proportion of light or radiation reflected by a surface. The main types are carbon asteroids, which have a very dark surface, silicon ones, you can also call them stone asteroids, and metal ones. The first two types account for around 75% and 17% of asteroids that we know about. For the first time, the asteroid belt was crossed by a spacecraft in 1972. It was the Pioneer 10 space probe. The spaceship managed to refute the theory that the belt was filled with dust that could easily damage all gadgets on board. It didn't happen. And since that time, 8 more probes have traveled through the asteroid belt. And now, I'm going to tell you some cool facts about the solar system itself. Try to count how many of these facts you've known before and write your answer down in the comments below. The solar system is a staggering 4.5 billion years old. Scientists came to this conclusion after studying meteorites, the oldest material they managed to find. But our solar system isn't the only one in the Milky Way galaxy. The galaxy we live in houses about 100 billion star systems. And if it's just our galaxy alone, what can we say about the whole universe? Now, our Sun is also insanely massive. Here's the proof. 99.86% of all the mass of the solar system is the mass of the Sun, in particular hydrogen and helium that it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Oh, by the way, contrary to popular misconception, outer space isn't a perfect vacuum. It contains not only stars and planets, but also clouds of interstellar dust, space plasma, and cosmic rays. Those are atom fragments dashing from the outskirts of the solar system. Now, one phenomenon astronauts should worry about while exploring space is cold welding. If two pieces of the same kind of metal touch in space, they bond and get permanently stuck together, kind of like galaxy glue. It doesn't happen on Earth since water and air keep pieces separate. You can see solar eclipses even though the Moon is 400 times smaller than the Sun. It's also 400 times closer to Earth, so it's perfectly capable of obscuring the star. But in 600 million years, the Moon won't be able to block the Sun completely because of the satellite's changing orbit. Behind the orbit of Neptune, there is the mysterious Kuiper Belt, filled with massy icy objects. The most curious thing about this space formation, though, is that the scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. The ocean on Jupiter is larger than any body of water on other planets of the solar system. But it's not the ocean you think about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is around 25,000 miles, which is actually almost the same as the circumference of Earth. Now, people got to know about beautiful Saturn's rings in the 1600s, but now we know that Saturn isn't the only ringed planet. All the giant gas planets, Uranus, Neptune, and Jupiter, have rings of their own, but they're thin and almost impossible to see. As for Mars, Venus, and Earth, they're made of rocky material and have no rings. At the same time, Saturn's moon Rhea might have a ring system consisting of 3 narrow bands. If astronomers manage to confirm it, it'll be the first time for people to discover rings around a moon. Oh, and Mars might get a set of rings of its own in the next 70 million years. The red planet's largest moon, called Phobos, is orbiting closer and closer to the planet. One day it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. And another cool fact about Mars. You've probably heard of methane gas, a byproduct of such natural processes as volcanic activity and cow emissions. Anyways, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be life on Mars? Can there be cows on Mars? So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Yeah, sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet.
Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD 20794d, and it's located 19.7 light-years away from Earth in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using two powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye, unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. astronomers have long suspected it had multiple planets. In 2011, scientists discovered two other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD 20794d. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD 20794d is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, the planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, they certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD 20794d into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the two other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 20794d only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light-year is around 6 trillion miles. The planet is called TOI 715b, and it's about 1.5 times the size of Earth. Unlike HD 20794d, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI 715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI 715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI 715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth, about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, this planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close to their stars.
At the edge of our solar system, there's a cold and mysterious region known as the Oort cloud. It's a hypothetical vast area of icy space objects surrounding the Sun. It's believed to lie far, far away from our star, from 2,000 to 5,000 astronomical units. For comparison, Pluto's orbit carries the planet between 30 and 50 astronomical units from the Sun. And there, in this freezing emptiness, a rogue planet may be hiding right at the moment. At least, that's what new research has recently suggested. Rogue planets are called this way because they don't orbit around any star. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Rogue planets are usually kicked out of their planetary systems, doomed to a solitary existence of circling the center of the galaxy on their own. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. At the same time, there might be billions or even trillions of rogue planets wandering around our galaxy. If these estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Anyway, in 1907, one astronomer started a search for Planet X. It's a hypothetical giant planet moving around the Sun beyond the orbit of Neptune. The scientist was convinced that this planet existed because he had observed some irregularities in the orbits of Uranus and Neptune. His idea led to the discovery of Pluto in 1930. But the dwarf planet was too small to have any serious. gravitational impact on the orbit of Neptune, let alone Uranus. These days, the Planet X theory is largely considered to be discredited, but it hasn't stopped astronomers from searching for planets in the far reaches of our solar system. And shockingly, a new study claims there might be one or even more out there, but much, much further away than predicted. An international team of scientists has recently simulated the unstable celestial mechanisms of the early solar system. They've discovered that there's a possibility that a few planet-sized bodies might have come to rest in the Oort cloud. You see, about 4.5 billion years ago, when the solar system was just forming, it was a hectic and unsettled place. Gravity sent debris from the cooling protoplanetary dust cloud hurtling around like cosmic tennis balls. From time to time, large chunks of this debris, even planet-sized ones, were sent flying far enough to escape the sun's gravity altogether. Such pieces of debris turned into rogue planets. Researchers have seen such space wanderers in distant exoplanetary systems, but according to them, there's a 0.5% chance that one or more of those wayward planets formed in the solar system and ended up in the Oort cloud after drifting away from the sun. At the same time, it's slightly more likely that a rogue, Neptune-like planet was snagged by the sun's gravity from another planetary system, and then this planet came to rest somewhere in the Oort cloud. The chances that this scenario is true reach 7%. If this turns out to be the case, then a space body similar to Planet X might indeed be hiding out there, on the outskirts of our solar system. The only problem is that it would still be too far away to have any impact on Neptune's orbit. In any case, most researchers are convinced that the Oort cloud is made up of a collection of way smaller icy objects. But given the distance to the Oort cloud and its enormous size, we may never really figure out what is lurking out there.
Can a planet be bigger than its parent star? Well, if you mean a star like our sun, it's highly unlikely. But what if it was a white dwarf, the remnant of a star similar to ours that went out after shedding its outer layers and leaving behind nothing but the core? This core is what we call a white dwarf. Usually, it's around the size of our home planet. If a star had a planet bigger than Earth before it extinguished, it's possible that such a planet could survive all the chaos. In this case, a planet that is bigger than its star might actually exist. And we've even found planetary systems like this. But there's one problem. A white dwarf isn't a real star like our sun anymore. It doesn't produce energy, just sits out there getting cooler and cooler. So probably such systems don't count. For comparison, the sun is working non-stop. It is fusing hydrogen into helium in its core. It has been doing it for more than 4 billion years and is going to keep doing it for the next 7 or 8 billion years. The sun is 10 times as wide as the largest planet in our solar system, gas giant Jupiter. And sadly, you can't get a planet much larger than that. If you start adding mass to such a world, it will get smaller, not bigger. So it seems you can find a planet larger than the sun. But there are also dim red dwarf stars. They're the smallest out there, barely massive enough to maintain fusion in their cores. The tiniest stars that we know about have been discovered recently. If astronomers' conclusions are correct, then both of them can hardly fuse hydrogen into helium. And it takes about 0.077 times the sun's mass, or 75 masses of Jupiter, to be able to do that. And still, they're real stars, just very tiny, smaller than Jupiter. One of them is only about the size of Saturn, which must mean that stars can have planets bigger than they are, right? Well, theoretically. When it comes to practice, you can hardly find such planetary systems. We've found and observed quite a lot of exoplanets, which are worlds orbiting other stars. It seems that there are indeed loads of trends out there in space, different masses, sizes, brightness, and so on. But the main trend? Red dwarfs don't usually have gas giants orbiting them. If they do have planets, those are typically small, rocky worlds, more like Earth. Those are also called terrestrial planets. For example, a red dwarf called TRAPPIST-1 has 7 Earth-sized planets orbiting it. But gas giants circling around red dwarfs are extremely rare. Hardly 1 in 100 tiny stars can boast such a planet. This number can be even smaller since the research has been done using candidate planets which haven't been confirmed yet. Plus, the smallest stars are also the dimmest. It means they are extremely hard to detect, and it's incredibly hard to figure out whether they have planets orbiting them, and if they do, whether these planets are gas giants or terrestrial worlds. Still, it's possible that a system where the planet is larger than its parent star exists. But the probability is statistically very low. At the same time, red dwarf stars are very numerous. They're actually the most common kind of star in the galaxy, making up around 70% of all stars. And even though really tiny red dwarfs are relatively rare, there still must be millions or probably even billions of them in the galaxy. And if there's even a small fraction of red dwarfs with gas giants orbiting them, it might still mean that a lot of such systems exist in total, and some of them can have planets bigger than their host star. How about a mysterious object that used to orbit between Mars and Jupiter? At one point in the early days of the solar system, it was destroyed by some catastrophic event. This space body is called Phaeton, and this planet is totally hypothetical. But some people believe that the debris the planet left behind could have formed the asteroid belt. If you like this kind of content, please give it a non-hypothetical like and subscribe. Your support is very important to us. Thank you. Now, at the start of the 19th century, people hadn't discovered the asteroid belt yet. But in 1801, one astronomer spotted the largest asteroid in our solar system, Ceres. At that time, it was believed that a planet was orbiting between Mars and Jupiter, and Ceres seemed to be a suitable candidate. But the next year, another astronomer discovered one more space object with a similar orbit. It was an asteroid that was later named Pallas. These discoveries made scientists conclude that these two objects could have been fragments of the very planet that had once been dwelling between Mars and Jupiter. The following discovery of 2 more asteroids, Juno and Vesta, seemed to confirm this idea. Only in the 20th century did the hypothetical planet get its name, Phaeton. It was actually a name taken from Greek mythology, meaning shining one. The hero with this name was the son of the sun deity, Helios, who rode his solar chariot across the sky every day, giving humans the heat and light necessary for survival. One day, Helios allowed Phaeton to drive his chariot. But the sun didn't manage to control the horses. Everything went wrong, and Earth was about to burn down. That's why the main deity, Zeus, had to stop Phaeton with a thunderbolt. The idea of the asteroid belt being the sad result of the planet's destruction was called the disruption theory. And of course, there were several ideas explaining the planet's tragic fate. The most obvious one is that Phaeton was hit by a large space object. It could be another hypothetical body called Nemesis. Some people believe that it's our sun's companion star. According to this theory, the sun has a small companion star that has an extremely elliptical orbit. This orbit periodically brings it close to the Oort cloud, a large sphere of icy objects surrounding the sun. This, in turn, causes a lot of mess. It might be the reason why this hypothetical companion star was also nicknamed the Death Star. It might be a red or brown dwarf. But whatever it is at the furthest point of its orbit, it's believed to be about 1.5 light-years away. The search for this star has been in progress for decades, but no one has succeeded in locating this elusive and potentially non-existent space object. Anyway, back to Phaeton. Another theory claims that the planet could have suffered some internal cataclysm which tore it apart. But these days, the disruption theory has fallen out of favor. It was replaced by the accretion theory. According to it, the asteroid belt formed in the process of gradual buildup of particles initially floating in a gaseous environment. With time, they came together to create larger masses. Gravity pulled on these particles, encouraging them to stay together and form planetesimals, tiny planet-like bodies that later form real planets. Planetesimals kept colliding with one another, eventually developing into protoplanets. Such protoplanets grow until they form planetary bodies. As the mass of objects increases, the gravitational forces acting between particles become stronger too, continuing to build gas, dust, and ice within the nebular disk. It all has a snowball effect where the increase in mass results in more particles getting involved in the process. Eventually, there's no building material left, and large space objects float in the darkness of space. Now, many experts think that the asteroid belt is the remains of the protoplanetary disk which had once been orbiting the Sun before the planets formed. Unfortunately, it never had a chance to coalesce into a planet because Jupiter's gravitational effect prevented it from happening. In any case, even though Phaetons was a good story, it's not popular anymore.
The red, parched earth under your feet is shaking. Large cracks are opening in the ground, threatening to swallow you. But unlike on Earth, these quakes aren't coming from within the planet. A threat coming from space is triggering them. Scientists have made a shocking discovery about Mars quakes. By using AI and NASA's InSight data, they found out that some of those tremors are caused by meteorite impacts. It means that Mars gets hit 2.5 times more often than we thought, and new craters are forming all the time. But the scariest part is that these impacts don't just shake the ground. They send powerful shock waves deep into the planet, revealing a hidden seismic highway and an unstable interior, unlike anything we imagined. This changes everything we thought we knew about Mars. So now, the big question is, what else is lurking beneath the surface? But let's follow scientists' train of thought first. They took Marsquake data from NASA's InSight lander and compared it with fresh impact craters spotted by the Mars Reconnaissance Orbiter. That's when they discovered that some impacts create a seismic highway through the mantle instead of being absorbed by the crust. Even though NASA shut down InSight in 2022, its data is still precious. The lander, which placed a seismometer on Mars, recorded over 1,300 Marsquakes, some caused by underground rock cracking under heat and pressure, others, apparently, by meteoroids slamming into the surface of the red planet. By studying how seismic waves move through the crust, mantle, and core, scientists keep piecing together Mars's deep structure. In the past, researchers already linked impact craters with seismic data. But these new studies are the first time when a fresh impact has been connected to quakes detected in Cerberus fossae. That's a highly active region 1,000 miles away from InSight. Scientists have discovered this 71-foot-wide crater much farther from NASA's InSight lander than expected, if we consider the strength of the seismic waves it produced. Mars's crust was thought to absorb most of the energy from impacts, which would limit how far seismic waves could travel. But the analysis of this crater revealed that, instead of getting dampened, the waves took a more direct and deeper path through the planet's mantle. This unexpected finding suggests that Mars has a seismic highway, which allows quakes to spread much farther than previously believed. Now, the InSight team will need to reassess their models of Mars' internal composition and structure. And then, we might better understand how impact-generated seismic signals can reach such depths. Manually sorting through the vast amount of data would have taken years. But luckily, these days, there are new tools, and scientists can go from tens of thousands of images to just a few in a matter of days. So, researchers focused on finding craters within approximately 1,800 miles of InSight's location. Their aim was to identify those that formed while the lander's seismometer was active. By comparing before and after images from the context camera over time, they identified 123 fresh craters to cross-reference with InSight's seismic data. Out of those, 49 craters were potential matches for quakes detected by InSight's seismometer. And after conducting some more analysis, the team decided that the 71-foot Cerberus fossae impact crater was the main finding. This discovery is likely to help scientists differentiate between signals from internal quakes and those caused by meteoroid impacts. Initially, they believed that Cerberus fossae produced a lot of high-frequency seismic signals linked to quakes originating inside Mars. But the new data suggests that some of this activity may have been caused by impacts, not internal processes. Another mystery scientists haven't been able to crack for 50 years is why Mars is split into two very different halves. But thanks to recordings of Marsquakes, they may have finally found the answer. Since the 1970s, researchers have known that Mars has two distinct regions. The northern lowlands cover about 2/3 of the planet's northern hemisphere, and the southern highlands make up the rest. The southern highlands sit about 3 miles higher than the northern lowlands, and the crust, the planet's outer layer, like a shell, is thicker in the south. This strange divide is known as the Martian dichotomy. There are two potential explanations for this imbalance. One theory suggests that an unknown internal process within Mars created the difference. The other claims that a massive collision, probably with a moon-sized space rock or several smaller impacts, once reshaped the planet's surface. But Mars' surface is extremely old. That's why pinpointing exactly what happened has been difficult. But now, a new study, published on December 27, 2024, has used Marsquake data from NASA's InSight lander to figure out whether the cause of this difference lies deep inside the planet. InSight was positioned near the boundary between the northern lowlands and southern highlands. Its mission included recording seismic data from Marsquakes, which travel through the planet's mantle, the rock layer beneath the crust. So scientists compared how these waves moved under both lowlands and highlands. They looked for differences in the planet's deep interior. It turns out that the seismic waves lost energy much faster when traveling through the southern highlands. It means that the mantle beneath this region is significantly hotter than in the north. It's compelling evidence that internal planetary forces, rather than an external impact, caused Mars' unusual split. The research team believes that the temperature difference between Mars' two halves can be traced back to ancient tectonic activity. It once shaped the planet, but later stopped. At some point in the past, Mars had moving tectonic plates, like Earth's. As these plates shifted, they, along with the molten rock beneath them, could have created the Martian dichotomy. But eventually, the movement stopped, leaving behind what scientists call a stagnant lid. That's a thick, immobile layer over the planet's molten interior. If this turns out to be true, it might mean that the mantle beneath the southern highlands is still pushing upward, while the mantle under the northern lowlands is sinking deeper toward the planet's core. This ongoing process could explain why Mars' crust is thicker in the south. At the same time, we can't completely rule out the idea that an external impact created the dichotomy. Some recent studies suggest that a giant collision could still be a possible explanation. To solve this mystery for good, scientists will need more Marsquake data and detailed models of how Mars originally formed. By the way, if you ever decide to visit Mars, you might come across the hero of our video today, the InSight lander itself. It was supposed to launch in March 2016, but a problem with one of its instruments caused a delay. It was a vacuum leak in the seismometer. NASA rescheduled the launch for May 2018, and the issue was fixed in the meantime. But this delay increased the total cost from $675 million to $830 million. Still, InSight successfully landed on Mars on November 26, 2018. But over time, dust built up on its solar panels, making it harder to recharge. The InSight lander runs on solar panels and batteries, but it needs occasional wind gusts, called cleaning events, to clear dust from the panels. Unfortunately, the place where InSight landed didn't get enough of these winds to keep the lander fully powered. By February 2021, during the Martian winter, thick dust had covered the panels, and they were only producing 27% of their full capacity. To save power, NASA started putting InSight into hibernation mode, shutting down instruments gradually to keep its electronics warm. They hoped better weather would allow the lander to recharge and wake up by July 2021. In May 2021, the team found a clever way to restore some power by using the lander's arm to move sand onto the panels, helping the wind clean off some of the dust. But eventually, InSight was only generating 1/10 of the power from the sunlight than it did right upon arrival. In July 2022, NASA put it in low power mode to keep detecting Marsquakes. The lander kept operating until December 2022. On December 20th, NASA announced that InSight had lost contact with Earth on December 15th, and the mission officially ended on December 21st, 2022.